In this lesson, I'm going to explain how to solve for molality and parts ratio. Also, make sure to hit the subscribe button to learn all about chemistry. So let's look at the problem. A solution of phosphoric acid was made by dissolving 8.00 grams of H3PO4 or phosphoric acid in 100.0 milliliters of water. Calculate the molality of the solution and assume water has a density of 1.00 grams per mil. So first off, what is molality? It's the amount of moles of solute over the kilograms of solvent. It's another way to measure concentration, similar to molarity. However, we express it with a lowercase m, and we use this equation, aka moles of solute over kilograms of solvent, instead of using moles of solute over liters of solution. So, the first thing we're going to want to do is convert this 8.00 grams of phosphoric acid into moles, since that's our solute. Now that we've converted to moles, we now have to convert the 100 milliliters of water into kilograms. And we can do this first by converting it into grams with the density that we're provided, and then by converting it from grams to kilograms. As you can see, we took 100.0 milliliters of H2O, or water, multiplied it by the density, aka 1 gram per milliliter, and then multiplied it by 1 kilogram per 1,000 grams. Now, this will give us our molality. And so we can simply plug this into our calculator. And you get about 0.816 molality solution. Let's try another problem. So, how many grams of a solute is needed to dissolve with 8,525 grams of solvent to create a 0.23 molality solution? The molar mass of the solute is provided as 55.845 grams per mole. So, how do we want to approach the problem? Well, first, let's set up the molality equation. Now that we have set up our molality equation, we need to do two things. Firstly, we need to convert the denominator into kilograms. The second thing we need to do is solve the amount of moles of solute. We can do this simply by multiplying both sides by our denominator. Now that we've found the amount of moles of solute that we have, we simply need to convert this from moles to grams to get our final answer. And we can do this by multiplying this number by the molar mass. Now we can simply plug this into our calculator. And you get about 109.498 grams. Now let's move on to parts ratio. So let's look at the problem. A jar contains 0.3 liters of water. If 2 moles of sodium chloride is dissolved in the jar, what is the concentration in ppm, or parts per million? So first, let me explain what actually is parts ratio. So parts ratio is simply the mass of whatever you're trying to calculate for in a solution over the total mass of the solution. And depending on if you're solving for parts per million or parts per billion, if you're solving for parts per million, you'll multiply that by 10 to the 6th. If you're solving for parts per billion, you'll multiply that by 10 to the 9th. The units that we want to use is either grams of solute over milliliters of solution times 10 to the 6th, or if we don't want to deal with this exponent, we can just do milligrams of solute over liters of solution. It's simply up to your preference. So I'm going to opt for the left one here. So we're going to solve first for the grams of solute by converting 2 moles of sodium chloride into grams. Now that we've converted the 2 moles of sodium chloride into grams, we now need to find the amount of milliliters of solution, simply by converting 0.3 liters into milliliters. Now that we've converted the amount of liters into milliliters, we simply need to multiply this answer by 10 to the 6th to get our concentration in parts per million. Now we simply have to plug this into our calculator and we'll have our answer. And we get about 3.897 times 10 to the 5th parts per million. Let's look at another problem. An Olympic-sized swimming pool contains 2,500,000 liters of water. If 6.75 grams of sodium chloride is dissolved in the pool, what is the concentration in parts per billion? So let me quickly bring back the formulas. And just to note, this unit here is micrograms, which is essentially 1,000 times less than a milligram. But anyway, I will opt for the left side anyway to solve for parts per billion. So first, we already have our solute in grams, meaning we don't have to do any conversions there. So let's put this in. Now, we need to divide by the amount of milliliters of solution. So let's convert 2.5 million liters into milliliters. Finally, we need to multiply this answer by 10 to the 9th, since we're working in parts per billion. Now we can simply plug this into our calculator. and we get 2.7 parts per billion. Thanks for watching. Make sure to hit that subscribe button to catch more chemistry videos just like this one.